Welcome to Chapter 11. Working backwards is this week's strategy. So let me go through a few examples here to demonstrate the problem-solving strategy of working backwards. If you were given directions, so in this example, Chad was given directions by Mike to get to his house. And Mike's directions to Chad went something like this. So leaving Chad's house, go 1, 2, 3 blocks, and then turn left. Now go 1, 2, 3 blocks and turn right. Go 1 block. Let's see, turn right first. Go 1 block, and now turn left and go 2 blocks. And you'll be at Mike's house. Now the problem is nobody told Chad how to get home, but luckily he knows the working backwards strategy. So he turn around and starting at Mike's house, he's going to go 1, 2 blocks. But last time when he was told to turn left, now he knows since he's working backwards, he's going to do the opposite. So he's going to turn to his right and go 1 block. And now, because last time he was told to turn right at this intersection, he knows to turn left and go 1, 2, 3 blocks. And finally, he's going to turn right because last time he turned left. So it goes down here and goes 1, 2, 3 blocks, and he's back at his house. Here is our second example in the working backwards strategy. I'm going to ask you to pick a number. Now, if we were together, I would do this with you, but I'm going to pick numbers for you, so follow along. I would ask you to pick a number and then add 5 to your number, and then multiply that result by 4, and then subtract your current result, subtract 6 from that current result, then divide your current result by 2, and then ask you for the final number. So as an example, let's just say you picked 6. Now this would be something you would do and you wouldn't tell me. Then if you added 5 to that, you would now have 11. And if you multiplied by 4, you'd now have 44. And then subtract 8, you would have 38. And of course, feel free to use a calculator on this. When you divide your current result by 2, you get 19. And so you would tell me you have 19. And then what I would do is I would come back and try to figure out what your what number you picked originally. In other words, what was that original number that you picked? And the way I would do it is I would list out, as these were being read off, I would list out what you were doing. So I would list out that you added 5, and then I'd list out that you multiplied by 4, and then you subtracted 6, and then you divided by 2, and finally you got 19. So the way I would figure out what your original number was, I would work backwards. I would say, all right, if you ended up with 19 and you divided by 2 to get that, then before you divided by 2, you must have had 38. So in other words, I multiplied by 2. And then before you had 38, you had something that you subtracted 6 from. So to figure out what that is, I would add 6 to get 44. And then you multiplied 4 to get 44, so I would divide by 4 to see that you had 11 here. And then finally, you added 5 to your original number to get 11, so I would subtract 5 from 11 and get 6. So in that way, I was able to work backwards. And just like in the map example, I did the opposite of what I was originally told to get back to your original number. Now let me add one wrinkle to this. A similar idea, I'm going to ask you to pick a number, add 3, multiply by 4, add 8, but then here, and this is a fairly common example, you're going to subtract a quarter of what you currently have. And then finally subtract 2, and I'd ask, what's the result? So for example, if you were to pick, let's say, 12 here, and then add 3, you've got 15. Multiplied by 4, that is 60. Add 8, now you're at 68. And now you're going to subtract a quarter of what you currently have. And so you could throw this into your calculator this way. 68 minus 1/4 of 68. Which should be 68, let's see, that should be 68 minus 17. And so this is, what was that, 51. So now you're at 51, and then finally subtract 2 from that, and you'd have 49. And so I'd ask, okay, what number did you get? You would tell me 49. Now, working backwards when you have something like this can be challenging. But I'm going to follow the same process that I did before. So I start out writing down what you were doing as you were going through it. So I'd write out, okay, you started out adding 3. Then you multiplied by 4, then you added 8, and now you subtracted, and I want to be careful here, you're not subtracting 1/4, you're subtracting 1/4 of, and then I usually use something like of the remaining, so I use REM, or of current, to distinguish the fact that I'm not just subtracting the number 1/4. In other words, this was not 68 minus 1/4, it's 68 minus 1/4 of the remaining amount, the number that I currently have. All right, so I use some note to indicate that. And then finally subtract 2, and then what's the result? Well, it was 49. Now, how do you deal with this subtract 1/4 of the remaining if you don't know what was remaining in the step above? Because we're down here at the bottom and we only know 49. Well, first of all, we know that before you subtracted 2, you must have had 51. All right, so here's how I'm going to get the next number up here. So I need to add 1/4 of the remaining, with the 1/4 of the remaining up here. So up here, what must have happened was I had a number, and this is what I'm going to call the box method. And I'm going to split it into 4 because I took 1/4 of that number away. So I'm going to color that out, or X it out, and I'm going to say, all right, 51 must be the remaining 3/4. In other words, must be the remaining 3 boxes here. So how can I split up that 51 into those 3 remaining boxes? And you can just take your calculator and divide by 3. But that means there were 17 in all 3 of those boxes. But, of course, that means there must have been 17 originally in the first box that we took away. So now if I multiply 17 times 4, or if I add 17 to 51, that gets me all 4 of the 17s. All right, so that tells me the number I had before I subtracted 1/4 of the remaining was 68. And now the rest of this goes like we would think. Before I added 8, I must have had 60, so I subtracted 8. Before I multiplied by 4, I divide by 4 to see I had 15. And before I added 3, subtract 3, I must have had 12 to start. All right, one word of caution with this method. If you make a mistake and say, let's say I had 49 here, so I was told that we had 49 at the end. If I make a mistake and accidentally do the subtract 2, now I've got 47. And then if I try to do the box method with 47, so I know that I had 4, I could split it into 4, I took one of those away, So now if I try to take my 47 and split it into those three, it won't go in evenly. With all these problems, it should be a nice split. So if you divide 47 by 3, you're going to get a decimal, and that's not what we're looking for. So go back and say, all right, I must have done something wrong, and sure enough, I subtracted 2 when I should have added 2. Okay, that's it for working backwards.